Hi guys, I'm back. We're going to start working on our notes right now. We have four different things that we're going to talk about today. So we're going to do parallel and perpendicular lines, and then we're going to do horizontal and vertical lines, and then you'll start to see that there's a connection and an overlap between the two. I'm hoping that some of this stuff is stuff that you already know. Maybe you know all of it, and today will be an easy review day for you. I'm not sure how much stuff you actually know. So go ahead and flip to your notes, that first page. They're talking about parallel and perpendicular lines. So the first question is, what do they look like? So what do you know about parallel lines? I'm hoping that you tell me that they never cross. That's usually the answer that I get. We want to use the math word, which is that they never intersect. They never intersect. So you're writing that down. You can draw pictures of them. If you think of some examples, what are some examples of parallel lines? I usually get railroad tracks. That's a very common one. And so those are things that are parallel. Today we're talking about graphs. And so the more important part is that we need to know that parallel lines have the same slope, right? Slope gives students or gives lines direction. And so in order for them to not cross, they have to be heading in the same direction, same slope, right? So if they are both have a positive slope or they both have a negative slope, it has to be identical. Otherwise, eventually they're going to cross, and parallel lines do not cross. The next one there is, what do their equations look like? I gave y equals 3x minus 9 and y equals 3x plus 7. Two things. Slope-intercept form, so we're familiar with that. The slope on both of those equations is 3. And then what you notice is that their intercepts, their y-intercepts, are different. One has a -9, one has a 7. So they're not the same line. They don't have the same intercept, but they do have the same slope. Therefore, they are parallel lines. Okay, so that's parallel lines. Perpendicular lines, what do they look like? Parallel lines intersect, right? But more specifically, how do they intersect? Parallel lines should intersect at a 90-degree angle. Another word for 90-degree angle is a right angle. So perpendicular lines intersect at a 90-degree or right angle. What we need to know about, again, are their slopes. So their slopes are opposite reciprocals. Okay, so I'm going to ask you to try this just on the side of your paper in your head. That's okay. If I give you the number 3, what is the opposite reciprocal of 3? I hope you're thinking negative. That's the opposite, so change the sign. And reciprocal is turning it into a fraction, so -1/3. If you don't know that, write that down. So 3 and -1/3 are opposite reciprocals. Let's do another one. Let's say I give you the fraction 2/5. What is the opposite reciprocal of 2/5? Opposite would make it negative, reciprocal would flip it. So -5/2. -5/2. So 2/5 and -5/2. Here's a trick question. I know you like those. If I give you the number 1, what is the opposite reciprocal of 1? -1. When you take 1 as a fraction, it's 1/1, so the reciprocal is still 1/1, so it doesn't change anything. And so 1 and -1 are opposite reciprocals. Just to foreshadow what is yet to come, and I want you to maybe be thinking about it and rolling it around in the back of your head, we're going to talk about a slope of 0. And I want you to start to think about what does it mean to have an opposite reciprocal of a slope of 0, and how do you get a slope of 0? So those are some of the things that I want you to be thinking about as we go on. All right, let's jump into our examples. So go back to your notes. We've got examples of y equals 3x minus 9 and y equals -1/3 x plus 7. So again, intercepts are different, slopes are opposite reciprocals. Example number 1. It says, what is the slope of the line parallel to -3x minus 7y and equal to 21? So if you're talking parallel lines, you have to know the slope. In -3x minus 7y equals 21, what form is that in? Well, that form is standard form. And so you don't know slope, but you can change it into slope-intercept. So you can see the work there. We added the 3x divided by the -7, and you get a -3/7 x minus 3, and you have a slope of -3/7. So you got it there. Okay, now you're taking the exact same equation, so negative 3x minus 7y equals 21. We already solved it and put it in a slope-intercept, so you can see it there. And it's asking you for the perpendicular slope. So opposite makes it positive, reciprocal flips it. So the slope is 7/3. Okay, so again, example 1, slopes are the same. Example 2, slopes are opposite reciprocals. That's what you need to know. Okay, let's keep going. Example number 3 in your notes. It says, write the equation of a line perpendicular to y equals -1/2 x minus 3 that passes through the point 2, 1, then graph both equations. Equations should be in slope-intercept form. So the equation they gave you, slope-intercept form. So the first thing you have to do is identify the slope of a line that was given. If you look at that, the slope is -1/2. Because you are working with perpendicular, so you're going to have to read carefully, perpendicular, the slope is going to be an opposite reciprocal. So it's going to be positive and you're going to flip it. So the slope that you're going to use is 2. So you have a slope. What other piece of information do you have? What else did they give you? They gave you a point. The point is 2, 1. So you found the slope 2. They gave you a point 2, 1. So you know what form? You can't use slope-intercept because you don't have an intercept. But you can plug it into point slope and change it. So that's what the work is that you see there. We plugged it into point slope. Y minus 1 is equal to 2 times the quantity x minus 2. Simplify that down. Distribute. Add the 1. Y equals 2x minus 3. Okay, both of them are graphed over there on the left-hand side. Maybe what you noticed about the equations is that they do have the same y-intercept, and that's where they intersect. And they intersect and they form what looks like 90-degree angles. So there it is for you. Okay, let's go to example number 4. It says, write an equation of a line that is parallel. Again, read carefully. Maybe you want to circle that word. Maybe you want to highlight that you know that it's parallel, so that changes things. Parallel to y equals 2x minus 3 and goes through the point -2, 4. And then graph both equations. So what is the slope of this line? The slope of this line is 2. Because you're talking parallel, the slope should be the same. So you're also going to use 2. Again, they gave you a point. So you have a slope and a point. You're going to plug it into point slope form, distribute, and add. Y equals 2x plus 8. 2x plus 8. Graph the first one. Intercept is at -3 up to right 1. Graph the second one. Intercept is at 8 up to right 1. Or you could also go down to left 1, down to left 1. And you get parallel lines. Parallel lines have the same slope. The same slope. One more example. Example number 5. Example number 5 says, write the equation of the line perpendicular to 3x minus 3 that goes through -3, 6. Then graph both equations. So pull out the slope from the line they give you. What slope did they give you? 3. But you're not going to use that slope. You are going to use the opposite reciprocal. So you take 3 and you change it into -1/3. -1/3. Take the point they gave you, -3, 6, and the slope that you found, -1/3, and you plug it in. That way you have slope, point slope form, and you can change it into slope intercept form. Again, distribute the -1/3. I know you hate fractions, but you can do it. It's -1/3 over 3 times 1. That's 3 over 3, and so that ends up being a -1. Add your 6. Y is equal to -1/3 x plus 5. Okay. All right. I am going to put up a you try problem, and hopefully you can try this on your own. Let me see. All right. There is your you try problem. Try that on the whiteboard. Okay, so how did you do with those whiteboard problems? Write the equation of the line that is parallel to 3x minus y is equal to 4 and goes to the point 1, 2. First thing you should have done is change it into slope-intercept form and pulled out the slope. So hopefully you found that the slope or sorry, slope-intercept form should be y equals 3x minus 4. Y equals 3x minus 4, you pull out the slope of 3, plug it in. Here is what your final answer should be for the first question. First question should be y equals 3x minus 1. Y equals 3x minus 1. Second, perpendicular. Again, take it and change it into slope-intercept form. So slope-intercept form for this second question should be y equals 2x minus 5/3. Y equals 2x minus 5/3. Take the slope of 2. Because you're working with perpendicular, it should be opposite reciprocal. Opposite reciprocal of 2 is negative 1/2. Plug it into point slope and change it. Your answer, y equals negative 1/2 x minus 4. Y equals negative 1/2 x minus 4. All right, let's keep going. Go back to your notes. And you've got a block of 6, 7, 8, and 9 that we're going to work on. 6, 7, 8, and 9. So are these lines parallel or perpendicular or neither? What are you comparing every single time? Slope. You don't care about the y-intercepts. You just care about slope. So number 6, as you're working through it, you can identify slope right off the bat. M equals 3 in the first one. M equals 3 in the second one. Answer, parallel. Number 7. M is equal to negative 1/3. Your other M is equal to 3. Negative 1/3 and 3. Clearly not the same, so not parallel. Are they opposite reciprocals? One is positive, one is negative. One is 3, one is 1/3. Yes, perpendicular. Number 8. First one, slope is 1/2. Second one, slope is 2. Parallel? No, they're not the same. Perpendicular. They are reciprocals, but are they opposite? No, one's positive and the other one's positive. They can't both be positive. So that falls in the neither category. Last example is a trick question, kind of. Do you know the slope for the second line? You don't. It's in standard form. You have to do the work to change it. So you're going to change it into slope-intercept. You can see the work there. So you would subtract the x, divide by 7, and get a slope of negative 1/7. So first equation has a slope of 7. Second equation has a negative 1/7. Are those the same? No, so not parallel. Are they opposite reciprocals? One's positive, one's negative. One is a 7, one is 1/7. Yes, those are reciprocals. So opposite reciprocal makes that perpendicular. So those are perpendicular. Okay, let's go down to 10 and 11. Again, same type of question. Are they parallel, perpendicular, or neither? You don't have any slopes at all. You have to do the work. Slope of the first line, if you need a refresher on your formula, m is equal to y2 minus y1 over x2 minus x1. That's what you should be using for both of those. When you plug your points in, you get slopes of negative 1/2 and you get a slope of 1/2. Are those the same? No. Are they reciprocals? No. They're opposites, but they're not reciprocals. So that's neither. Go to number 11, same thing. Plug in your values for slope. Negative 7 minus a negative 1, so plus 1. 6 minus 2, reduce that, negative 2. 2 minus 0, negative 1 minus 0, negative 2. Negative 2 and negative 2 are the same, so those are parallel. So those are parallel lines. Okay, we're going to do some whiteboard practice starting with the next video. So put your notes away for a minute and take out your whiteboards, please.